So we'll start with a joke. And this is Chemistry Cat, for those of you who don't know Chemistry Cat. And the joke says, teach us about absolute zero. And it says, okay, but in actuality, if you look, absolute zero is 0 Kelvin. Okay? Get it? Oh, Mrs. Garvin, you are so hilarious. Okay, now let's start our notes. So title of the notes is going to be Changes of Phase. And matter basically comes in 3 phases. 1, 2, and 3. And hopefully you guys know those phases, which are solid, liquid, and gas. And basically what we're going to do today is be able to calculate the heat change when you go from a solid to a liquid, or from a liquid to a gas, or from a gas down to a liquid. Now I'm going to go ahead and write solid, and then I'm going to write liquid in the middle, and then I'm going to write gas towards the end of the page. And I'm going to draw a line between solid and liquid, and a line between liquid and gas. Now, when you go from a solid to a liquid, for example, when solid ice changes to liquid water, that is called fusion. So when I'm going, notice in the right-hand direction, when I'm going from a solid to a liquid, that change of phase is called fusion. And if you want to go from ice to water, you have to add heat. So that is endothermic. Now to go from a liquid to a gas, so you're taking, for example, liquid water and you're turning it into water vapor, that is called vaporization. And I'm using my arrows to indicate that I'm going from a liquid to a gas. Now vaporization, in order to get from liquid to a gas, you also have to add heat. Zoom in. And that is endothermic also. No, it's blurry. Let's see if we can focus that. That's better. Okay. Now to go the opposite way. Let's say we want to go from a gas down to a liquid. To go from a gas to a liquid, for example, taking water vapor and it turning into liquid water, that is called condensation. And notice I'm designating my arrows. And this condensation is the opposite of vaporization. So notice to go from a liquid to a gas, you had to add heat. Now to go reverse from a gas to a liquid, it releases heat. And that is therefore exothermic. And to go from a liquid to a solid. Now, the word to go from a liquid to a solid is a very complicated word. It's very, very difficult to remember. And that word is solid. Haha, fooled you. Not a very difficult word to remember. So to go from liquid to a solid is just called solid. That's that phase change. That's what it's called. And it also releases heat. Notice it's the opposite of fusion. To go from a solid to a liquid, that's called fusion. You had to add heat, so it's endothermic. So do the opposite of that, go from a liquid to a solid, that releases heat, which is exothermic. Okay, so now what I'm actually going to do is I am going to go ahead and write out the equation we're going to use, because we're going to be able to calculate how much heat needs to be added, or how much heat gets released. And that equation is Q equals M times delta H. Where Q is heat, energy, and that is in joules. M stands for mass, and that is in grams. And delta H is enthalpy, which is just a fancy schmancy word for heat. Now, if you don't have the worksheet printed out, I would go ahead and print it out now. You're going to need 17.4. Okay, if you don't have it, then maybe you can just write the problems in your chem journal. So at the top here, there's this whole space, and I'm basically just going to rewrite what I wrote right here. And so let's go ahead and do that. So solid, line, liquid, line, gas. And to go from a solid to a liquid, that is called fusion. I'm going to add my arrows. And that is endothermic. To go from a liquid to a gas, that is called vaporization. Add my arrows, and that is also endothermic. So endothermic is positive, remember that. To go from a gas to a liquid the opposite way, that is called condensation. And that's exothermic, negative. And then to go from a liquid to a solid, that is called solid. Very fancy word if you ask me. And we're going from right to left, and that is exothermic, negative. So basically you can see that fusion and solid are opposites of one another. So we've got this table here, and we have 4 different substances, and we have their formulas, and we have delta H values. Okay? And so these delta H values are going to be what we plug in right here for delta H. But notice I only have vaporization and fusion values. I don't have solid or condensation values. But I know that fusion and solid are opposites of one another, and the solid, going from a liquid to a solid, that is exothermic. That's negative. So the opposite of fusion is solid. So I'm going to say delta H solid. Right above fusion, I'm going to put a negative in front of it. Okay, and then vaporization and condensation, they're opposites of one another. So notice I don't have condensation values, but I do have vaporization values. So condensation is just going to be the opposite of vaporization. So I'm going to write negative delta H COND for condensation above this guy. So I'm going to do 2 problems. Number 1, how much heat is required to boil this many grams of water? So Q equals M times delta H, and I'm just going to plug in chug. They give you the mass, which is 3.6. Now, in this case, how much heat is required to boil water? Okay, so if we are boiling, we are going from a liquid to a gas. So that is called vaporization. So I'm going to write this is called vaporization. Now, vaporization is an endothermic reaction, so it has a positive sign. And this reaction is endothermic. So technically this is delta H of vape, V-A-P, delta H of vaporization, because it is boiling water, and boiling water is going from a liquid to a gas, which is called vaporization. So it's water, so I look up water, and I'm going to use the delta H of vaporization value, which is 2257, 2,257. So I multiply those two together, and my calculator spits out 8125.2. And you know what, just because this chapter is a little bit confusing, we're just going to give these problems 3 sig figs also. So 3 sig figs, that's going to give me 8130, and the units are joules. So that is how much heat is needed, okay, to boil this many grams of water. To go from a liquid to a gas, I'm going to need 8,130 joules worth of heat. Let's go ahead and let's do one on, or let's actually do number 2. So calculate the heat required to melt this many grams of ethanol. So if we are melting, it means we are going from a solid to a liquid. That is called fusion. So this is called fusion. Fusion has a positive sign, and to melt something, you need to add heat, so it's endothermic. So I'm going to write out my equation. Q equals M times delta H. Now it's delta H of fusion, of F-U-S, because it's melting, because we are going from a solid to a liquid. So let's go ahead and plug things in. My mass is 44.2, and my change in fusion for ethanol, delta H of fusion is 109. So my calculator spits out 4817.8. I'm telling you just to give you 3 sig figs. So it's going to give me 4820 joules. So in order to melt that many grams of ethanol, I have to add that much heat energy. Okay? So, yeah, I guess that's it. Let's see if I can find another good chemistry cat joke. I had one of my other favorites. Oh, I love this one. I realized I weighed nothing on a milligram scale, and I was like, OMG, oxygen, magnesium, but it's 0 milligrams. You get it down at the bottom, 0 mg, 0 milligrams. There she goes again, Mrs. Garvin being super hilarious. Okay, guys, well, I hope you have a good evening, and I'll see you tomorrow.